Today we're learning how to multiply radical expressions. The one thing you have to remember about multiplying radical expressions, radicals are like variables. So the same rules that apply for variables apply to the radicals. So if I have something like, let's say 2x plus 3x, can we add those together?
Yes.
What does that become?
5x.
Right, it becomes a 5x. But if I have 2x, or let me go back. Let me show you what it looks like as a radical. 2 radical 3 plus 4 radical 3. How many radical 3's do we have? How many radical 3's do we have, Dennis?
6.
6 radical 3's. I add the coefficients, just like I did here. Okay? But if the radicals are different, just like if I had 2x plus 3y, can they be added? Can they be added? No. I can't add 2 radical 5 plus 5 radical 2 because the radicals are different. Does that make sense? Okay, I'm going to erase. Now, if I multiply 2x times 3y, what do I do? Yeah. Actually, let's make it 2x times 3x.
So you multiply the coefficients
2
and
times
times 3,
3.
then x.
So we multiply coefficient with coefficient,
And
variable with variable. Same thing with radicals.
is 6 times
2 radical 5 times 3 radical 2. Okay? 2 times 3, coefficient with coefficient, radical with radical. So what does that simplify to? Neve?
6 radical
6 radical 10. And is there anything I could simplify out of that? No. So we treat the radicals just like variables. All right. So let's continue. Okay, so on this one, what's the coefficient of the first term? Neve.
5.
Of the second term.
Oh, 1.
1. So Ben, what am I multiplying?
5 by 1.
Okay, and
In the radical 2 times 7.
times radical 7. And what do I end up with, Ben?
5 radical 14.
Perfect.
And then you can simplify.
Can it be simplified?
Oh, no.
Because there's no perfect square in 14.
Yeah.
Okay, number 2, what else can I do? Benedict.
You multiply 2 and 3.
Okay, I'm going to multiply 2 times 3, and what else am I multiplying?
And radical 5 times radical 7.
And we end up with,
6 radical 35.
can that be simplified? Okay, next one, number 3. Somebody I haven't heard from, Flora.
You multiply 1 times 7,
1 times 7,
and you multiply 2 and radical 2 and radical 6.
good. And now 1 times 7 is 7, and that's a radical 12. Can radical 12 be broken down more?
Yes.
Is there a perfect square in it?
Yes.
Shh, Flora, what perfect square is in it? Think of the factors of 12. How do you make up 12? Flora, what times what equals 12? All right, somebody else? Okay, Joel?
4 and 3.
4 times 3. So 7 is times radical 4 times radical 3. Flora, what's the square root of 4?
2. I thought you meant like the same number times the same number.
No, okay. Times radical 3, and we end up with 14 radical 3. That should have been your simplified answer. You guys do 4, 5, and 6. All right, so number 4, what do we get? Benedict?
Do I just say the answer?
No.
Multiply 6 and 4,
Shh.
and radical 5 and 3. Radical 5 and radical 3.
Okay, and it turns out?
24 radical 15.
Okay, there we go. Next one. Grant.
You multiply 5 by 1 and 10 times 3, and you get 10 radical 30, or 5 radical 30.
So 5 radical 30. Last one. Let's go. Joel.
You multiply 3 and 2, and 5 and 10.
Radical 5. Radical 10. And we get...
And then you get 6 radical 50, and that can be broken down, so you do 6 radical 25 times 2 times radical 2, and then it's 5, so 6 times 5 is 30 radical 2.
All right, 30 radical 2. Final answer. Okay, so now... Okay, so if we're doing, now, we're going to distribute the same way we would with a variable. So, okay, just letting you know I'm recording, okay? So please try and stop all the back talk in the back. Okay, we're doing radical 7 times 3 is, yes, Kevin. 3 radical 7. Plus, next one, RJ.
Radical 14.
Right, radical 7 times radical 2 makes radical 14. Now, can these be combined? Are they like terms? No, they're not. So, this is as far as I go. I cannot combine them. Okay? Next one. Radical 2 times radical 6 is radical 12. And radical 2 times radical 10 is radical 20. Good. So, can either of those be broken down? Neve, how do I break them down?
Okay, both can be broken down. 12 can be broken down to radical 4 times radical 3.
Stop. Okay. And Flora, what am I breaking 20 down by? 10 and 2 does not have a perfect square. I need to pick numbers where there's a perfect square in there. Okay, Zoe? Radical 4 and radical 5. You got to pick the ones that have the perfect square. 4 is a perfect square. So the first term simplifies to Zoe. Two radical 3. Keep going. Minus. Good. Don't forget about that. Okay, you guys, you know what? I'd like you to try the next two, but I think we're running out. So I'm going to move on. We're running out of time. All right. If I have binomials, we just treat it the same way we've been multiplying binomials. We're going to FOIL or double distribute. 5 times radical 6 is 5 radical 6. 5 times negative 3 is negative 15. Okay? Radical 2 radical 6 is radical plus radical 12. And radical 2 times negative 3 is minus 3 radical 2. Can any of those terms be combined? Yes or no? Yes. Can any of those terms be combined? No. Okay, can anything be broken down more? Stacy. Radical 12 is made up of a radical 4 times 3. So, I'm going to say that's 2 radical 3 minus 3 radical 2, that negative 15, and 5 radical 6. Can I simplify this anymore? Can any terms be combined? Can I combine 2 radical 3 minus 3 radical 2? No. All right, pause the recording if you want to practice some more. And we're going to move on. Oh, let's take a look at what happens here in 3 because it's a little bit irregular. So as I do this, look at my terms. And the middle terms cancel out because this is a difference of squares. So then I'm left with 4 minus radical 36. What is radical 36? 6. So that's 4 minus 6, which is negative 2. Okay, so it's a little bit different. Yeah. Okay, when I'm double distributing, don't get confused just because I'm doing 3 radical 5 times 3 radical 5. We did that earlier in the lesson. Does that make sense? Are you guys confused? Okay. All right. So now multiplying with variables. Okay, radical 11 times radical x is what? Radical 11x. Can that be broken down? Okay. Now, this one, the next one, just think about it like I'm just doing the multiplication. It's radical x times x plus 5. You with me? And what does that simplify to? Plattner?
Radical x squared plus 5x.
Plus 5x. Can that be broken down anymore?
X?
Okay. Can we break that down? Yes, Vogel.
You can break down the x squared into x.
That's a binomial now. So I can't take part of it.
Can't break that down.
Can't break that down. So we're doing the same thing. Everything's under the radical. The quantity of x plus 2 times the quantity of x minus 3. And then I have to multiply it out because it's asking me to multiply. Don't factor it back out. This is the ending. If you try and factor, you'll end up with where you started. Don't do that. This is where you want to end. Okay? All right, let's keep going on. At one point, you're going to get these and they can't be simplified anymore. But sometimes, look, we can still, once I multiply them, I can break 12 down again. What perfect square is inside of 12, Flora? What perfect square is inside of 12? 4. So the 4 can be broken down. And notice my x to the 5th. I bring it down to the closest even number, which would be x to the 4th times x. Y to the 5th breaks down to y to the 4th times y. So my root of 4 is what? 2. The root of x to the 4th is x squared. The root of y squared is y 4th is y squared. And what's left inside the radical box? 3xy. Okay? And that's your final answer. Okay? Now, sometimes just gets... Now, just remember, with variables, if I have a squared and I'm multiplying by a squared, I really just add the exponents. Did you guys remember that? From back in chapter 5. Okay. Okay, so with the exponents for the variables, we're just adding the exponents when we multiply. All right, let's try. I want to go on to number 9, where you have a binomial. What is this going to simplify to? RJ.
So the first thing you do is break the first radical into x, the quantity of x plus 1.
Not yet.
No. All right, we'll multiply first. You
Okay.
get the radical x plus 1 to the 41st.
Perfect.
And then you break it up to 41.
So we're breaking down to the 41st. And how would I break that down?
And then radical x plus 1, the quantity of x plus 1 to the 40th, and then x plus 1.
Okay, so the quantity of x plus 1 to the 40th times the quantity of x plus 1.
And then
Closest even number. And what's the square root of x plus 1 to the 40th?
quantity of x plus 1 to the 20th.
The quantity of x plus 1 to the 20th. And radical x plus 1 to the first stays inside. All right? So this is 11, what did we say, 11-4? Yeah, 11-4. You know, here I would multiply the ones outside the binomial outside first. And look, your y minus 2 times y minus 2, combine it because it's the same base. So y minus 2 to the third, it will be y minus 2 to the fourth. Multiply everything outside the binomial. And then you can start breaking that down. Yes.
You write down 8, so you go.
18 is to what?
9
9 and
and 2.
2.
And then you can take the roots of 3y and y minus 3 to the second.
Okay, so the root of 9 is 3. The root of y squared is y. And the root of y minus 2 to the fourth is y minus 2 to the second. And then I'm left with inside 2, radical 2. Okay? And that's 11